Hello students, welcome back. This question is from GATE 2005 exam. It's also for 2 marks. They're trying to implement a NOR gate using multiplexers. So these are the inputs of NOR gate that they're trying to implement, and the expected output is A NOR B. Okay, we need to determine what are the values of X, Y and Z such that we get A NOR B in the output. Okay. These are the 4 options. X, Y, Z can be any one of these. Okay. Now, before moving ahead, let us have a look at one property of NOR gate. I'm sure most of you know it, but still. So, whenever any one of the input of NOR gate is 1, whenever at least one of the input of NOR gate is 1, that means these 3 cases, the ones that I've highlighted. In these 3 cases, the output will surely be 0. The output is only high when both the inputs are low. Okay. Keeping this in mind, let us have a look at this diagram. Now see, we cannot analyze this multiplexer until we have analyzed this, because we don't know what is this select line. Okay. But here we can know what is this select line. So see, this variable is Z, we need to determine it. X and Y, we need to determine them. Z can take 2 possible values, A and B. Okay, let us try with A. So I'm connecting A here. A can be 0 or 1. Okay, let us assume A is 1. Then we'll just analyze the case when A is 0. For now, assume A is 1. See, we want A and B's NOR. If A is 1, the output is surely 0. We don't even need to check what is B. Now, value of B can be anything, be it 0, be it 1. The final output has to be 0, okay, according to this truth table, because at least one input is high. Now, whenever A is 1, that means select line is 1. This input will be selected and will be given as the output, okay, for this multiplexer. That means the output of first multiplexer will be A, because we have connected A here, and you very well know A is equal to 1, okay. That means when you connect A here and A is 1, this multiplexer will also get 1 as the select line. Now, actually, they have mentioned it in question that whenever select line is 1, the upper input will be selected as the output. That means this one. In this case, also this one. Okay, it is upper input. Anyways, it wasn't required to be mentioned because they have written 1 and zeros here. Still, let's just continue. You can see this is 1. That means this input will be selected as output. And we know because A is 1, that means these 2 cases, the output must be 0. According to this diagram, whatever is X, that will be given as the output. That means X must be 0. Okay, so we have made X permanently 0. Now let us analyze other case when A is equal to 0. Okay. This case. Now you can see when A is 0, this input will be selected. That means B will be selected and given as output. Okay. B can be either 0 or 1. So there are 2 cases. B is equal to 0 and B is equal to 1. Let us analyze them one by one. Suppose A is 0. This is fixed. Suppose now B is 0. We are talking about this case. Because A is 0, this input B will be selected and given as output. So you are getting B is equal to 0 here on the select line. Now because select line of this multiplexer is 0, this one will be selected and given as the output. Okay, so output of this multiplexer will be Y. A is 0, B is 0. None of the inputs of a NOR gate is 1. That means output must be 1. Okay, so you need the output 1. We have analyzed 3 cases. Only this case is left. That means A is 0, B is 1. Let us analyze this case now. So we are analyzing this one. A is 0. That means this input will be selected and given as output. This is B. So B will be selected and given as output. Value of B is 1 this time. Okay. So 1 will be given as select line to this multiplexer. That means its output is going to this one. Going to be this one. We have already connected 0 here. So output in this case is going to be 0. Let us see. See 0 and 1. 0 and 1. We wanted the output to be 0 only and we are getting 0. That means the values of x, y, z are 0, 1 and a. Let us see it. 0, 1 and a. So this is your answer. Answer is option D. Now let us see one more thing. Is it possible to construct a NOR gate if I connect B here? Okay. Last time we connected A here. Now I am trying to connect B on this input. Let us see if we are able to derive a NOR gate from this. So I'm erasing these inputs. See, let us analyze the case when B is equal to 1. B is 1. We have at least one input as 1. That means the output is going to be 0. Okay. So the final output that you want is 0. B is 1. That means whatever is connected to this input of multiplexer will be given as output. Okay. So the output is A. But there are two cases. A is equal to 0 or A is equal to 1. Okay. When A is 0, this one will be selected. Sorry, this one will be selected. When A is equal to 1, the upper input will be selected. But in both of the cases, because at least one input is 1, we want the output to be 0. So X will also be 0, Y will also be 0. Okay. Now let's analyze the third case. We have already analyzed two cases. B is equal to 1, A is equal to 0 and B is equal to 1, A is equal to 1. Now let's analyze the third case when this variable B is 0. Okay. When variable B becomes 0, this input will be selected and given as output. We'll get B here only and B is already 0. Okay. Whatever be the value of A, you will always get Y in output because select line of this multiplexer is 0. So the output will always be 0 irrespective of the value of A. Okay. So when B is 0 but A is equal to 0. Okay. Both of them are 0. In this case also you can see the final output is 0. Okay. But actually we wanted the output to be 1. So this is not possible. That means we cannot implement a NOR gate when this variable, this select line is B. It is only possible when select line is A. That means this select line has to be A if these are the inputs. Okay.